All right, for this section, one of the things that you're going to want to have to reference as you go through these problems is a list of squares and a list of cubes. And I'm going to go ahead and make those lists here. But make sure you write that down on a piece of paper so you can look at it while you're going through these problems. So squares, those are made by squaring something. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And this list doesn't need to be too long, maybe 121, 12, or 11 squared or 12 squared. And then as far as your variables go, they start with x to the second, which is just x times x. X to the fourth, x to the sixth. These go up by 2, so 2, 4, 6. X to the eighth, x to the 10th. And then cubes, sort of the same idea. You're cubing things. So 1 cubed, 1 times 1 times 1. 2 cubed, 2 times 2 times 2. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. Your list for cubes can be a lot shorter than squares just because you'll see a lot less cubes. As far as the variables go, it starts with x to the third. And then it goes up by 3, so x to the 6th, x to the 9th, x to the 12th, and then x to the 15th, and then so on. Number 1 says to rationalize in the directions. And basically what that means is that we're going to get rid of any radicals in the denominator. But there is, even though that's the instructions, there is something that you'll want to do before that if you can. So you'll want to simplify first. And what you'll want to do is look for, in order to simplify, look for squares or cubes. And since I'll put the little 2 here, since the index is 2, you're going to want to look for squares. So that list that we had on the first slide, you're going to want to see if any of those are factors of either 17 or 3. So I'll make that little list here: 1, 4, 9, 16. 16 doesn't go into 17 or 3, doesn't go into 9, or 9 doesn't go into 17 or 3. 4 doesn't, and neither does 1. So no squares in either of those. So this first step of simplifying we don't need to do. Next, I'm going to rewrite this, and we'll actually go through the rationalization process. So 17 over 3. And what we're going to do is, with square roots, it's fairly easy because you just basically multiply whatever the bottom number is. So we're going to multiply the square root of 3 on both top and bottom. And again, we're going to do that when it's a square root. When it's a cube root, we'll do something slightly different. But we'll continue on with this. So square root of 3 times square root of 3 on bottom, that gives us a square root of 9. Square root of 17 times square root of 3 on top gives us a square root of 51. And this helps us rationalize it because the square root of 9 on bottom just comes out to 3. Square root of 51, though, we don't know what that is. So just leave it as the square root of 51. But you might take a second to see if it has any squares in it. So 1, 4, 9, 16, 25. You really just have to go to about half of the number, and we'll check all these. 51 divided by 25 doesn't come out nicely. 51 divided by 16, 51 divided by 9, and 4. None of those are factors of 51, so we can't simplify it. And that's as far as that goes. Next up, number 2, 14 square root of 5 over 5 square root of 7. Same thing that we're being asked to do as number 1. We want to rationalize this, but first we're going to simplify if we can. So you're looking for, just in the 5 and in the 7, you're looking for squares. Since they're square roots, you got the little 2 in the index. So thankfully, 5 and 7 are low enough that you don't really have to check very many numbers. So 1 and 4. We don't do anything with 1, but 4 doesn't go into 5. It doesn't go into 7. And that's basically all you need to check for the simplifying part. So in order to rationalize, we've got 14 square root of 5 over 5 square root of 7. We're just going to multiply the radical that's on bottom. Square root of 7 over square root of 7. And this is what you'll do when you've got a square root. So you're just multiplying whatever the square root on the bottom is. So on top, we've got 14 square root of 35, the 5 times the 7. On bottom, we've got 5 square root of 49, which is the 7 times 7 there. Continuing on, 14 square root of 35. And on bottom, square root of 49, you might know, is actually just 7. So 5 times the square root of 49 is really 5 times 7. On bottom, 35. Be careful that you can't cancel the 35 on top and the 35 on bottom, because the 35 on top is a square root. 35 on bottom is not, so you're not going to reduce those. But the 14 and the 35 you can reduce by 7. So 14 reduced by 7 is 2. 35 reduced by 7 is 5. So ultimately we end up with 2 square root of 35 over 5. And again, with the 35 and the 5, they have a common factor, but the 35 is a square root. So you're only going to simplify with other square roots, and the 5 is not. And by the way, before you put in the confident final answer, make sure you check to see if this has any squares in it. Square root of 35, so 1, 4, 9, 16, 25, just to about half. And 35 divided by 25 doesn't come out to a nice whole number. 35 divided by 16, 35 divided by 9, 35 divided by 4. Once you've done that, you know you can't simplify it any further. And that's as far as that goes. Number 3, the square root of 2x over 45. I'm going to start out by splitting this up. We'll make it the square root of 2x on top. Actually, let's do this below. Square root of 2x on top, square root of 45 on the bottom. And we want to simplify this just to start with, and then we'll go about rationalizing it. So if we're going to simplify, we want to do this on top and bottom, but we're going to look for squares. And you want to do that on top and bottom. So squares, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And you really needed to go to just about half of the number. And 25 doesn't go into 45 or 2. 16 doesn't go into 45 or 2, but 9 does. So we're going to rewrite this on bottom as 9 times 5, since 9 times 5 is 45. On top, none of those go into 2, so we'll just leave that as 2x. And this square root of 9 part, that's actually 3. So on the next step, we've got 3, and then the 5 stayed inside. On top, still square root of 2x. And once you've simplified that, then we want to go ahead and rationalize. And when you're rationalizing and you've got a square root on bottom, you can just go ahead and duplicate that square root. We're going to multiply square root of 5 on top and on bottom. So on top, you multiply 2 and the 5, you get 10. And then we've got the x up there also. On bottom, we've got the 3 on the outside. It's not multiplying with anything really that's going to change. But the square root of 5 and the square root of 5 is the square root of 25. And then hopefully you guys know the square root of 25 is the same as 5. So instead of 3 times the square root of 5, it's really 3 times 5. So square root of 10x on top, and then on bottom, 3 times 5. $15 on bottom. And even though we've got 10 and 15, which have a common factor of 5, on top it's a radical, so we're not going to simplify with something that's not a radical. Okay, number 4. Here we're dealing with cube roots. We've got the cube root of 40 over 9. And whenever you've got a fraction, take a second to see if you can reduce. Since they're both under the cube root symbol, you can reduce any numbers that have a common factor. 40 and 9, though, don't have anything in common, so we can go ahead and move on from there. First thing I'm going to do is split these up. We'll make it the cube root of 40 over the cube root of 9. And if that were a square root on bottom, we would go ahead and simplify it to 3. Or if it were a square on bottom, a lot of times you can just multiply it by the top and the bottom and go on from there. But with a cube root, what we're going to do in order to rationalize this is we're going to multiply it by something that's ultimately going to give us a cube root on bottom that would simplify. So we're going to multiply it by something that would give us, say, 27, which is a number that you can get 9 to. But even if you don't think of it in those terms, I'll go ahead and erase this. You can multiply it by the square root of 9, which would be 3, or the square of 9, which would be 81. So, I mean, if we're deciding whether we're multiplying 3 or multiplying 81, 81 is going to be a large number. It'd be better if we just multiply a smaller number. So we're going to use the square root instead of the square, just because it keeps things smaller. So the cube root of 3, we're going to multiply on top and bottom, and then we do get the cube root of 27. That's going to simplify to where we don't have a radical on the bottom anymore. On top, when we multiply both of those, we get the cube root of 120. Taking this just a little bit further, the cube root of 27 on bottom is 3. On top, the cube root of 120 doesn't come out nicely if you put that in the calculator. So in a lot of cases, you might end at this point, but we want to check to see if there's any cubes in that 120. So 1, 8, 27, 64. So you're going to take 120 divided by those and see if anything comes out. 120 divided by 27, 120 divided by 8. That actually comes out to 15. So you're going to want to rewrite that 120 as 8 times 15. On bottom, we've got 3, and this will simplify because the cube root of 8 is 2. The 15 stays inside, and then we've got 3 on the bottom. All right, number 5, cube root of 2y to the 4th over the cube root of 6x to the 4th. And like I said on the last one, if you've got a radical on top and a radical on bottom, and you've got numbers that reduce, you'll want to go ahead and reduce those. 2 and 6, you can reduce by 2. So 2 becomes 1, the 6 becomes 3. So I'll rewrite this, cube root of y to the 4th over cube root of 3x to the 4th. And then next thing that we'll do is we'll try to rationalize this. And on bottom, you're going to multiply by something, the cube root. That's going to ultimately give you something that 3 goes into. So a cube that 3 goes into. So cubes, you got 1, 8, 27. 3 doesn't go into 8, but it does go into 27. So if you can ultimately get it to 27, that would be ideal. So just like on the last one, just a kind of a shortcut, you're going to take it by the cube root, or not cube root, the square root, even though this is cubes that we're dealing with. Taking it times the square root or the square. So the square root of 3, we don't know what that is. If you put that in a calculator, you get an irrational number. Square, though, the square of 3 is 9, so that's pretty easy. Doing that the same on top and bottom. But we'll want to make sure that our variables, so the x to the fourth and the y to the fourth, we want to make sure that they end up, or the x to the fourth rather, on bottom. We want to make sure it ends up as a cube also. So if we're looking at the cube variables, we've got x to the third, x to the sixth, x to the ninth. We want to make sure that that x to the fourth ends up as one of those. It's too large to end up at x to the third, but we could get it to x to the sixth if we take the x to the fourth times x to the second. So do that on top and the bottom. So when we do that multiplication, we're going to end up with x to the sixth. That's a cube that'll simplify. And we'll go ahead and do that multiplication. So 3 times the 9 will give us that 27, which is a perfect cube. X to the fourth times x to the second will give us x to the sixth, which is a perfect cube. And then just do the multiplying on top. We've got the cube root of 9, x to the second, y to the fourth. Continuing on the bottom, all of that should come out. The cube root of 27 is 3. X to the sixth, when you take it out, divide the exponent by the index. So the 6 divided by 3 will give you x to the second on the outside. On the top, we've got 9x to the second, y to the fourth. None of those should be perfect cubes, but we do want to check to see if there are any cubes in there. X to the third is our first variable cube, and you can't get x to the third from x squared, but with the y to the fourth, you could write that as y to the third times y to the first. Three x squared still on the bottom. So on the next step, I'll do some white. The y to the third is going to come out. Remember, you're going to divide that exponent by the index. So we've got y to the first now on the outside, 3 divided by 3. And then on the inside, 9x to the second, and then that other y to the first that didn't come out. And then on bottom, 3x squared. Number 6, cube root of 5 over 2, x to the 14th, y to the second. Start out by splitting this up. Cube root of 5 over cube root of 2, x to the 14th, y to the second. If you can reduce the 5 and the 2, you'll want to go ahead and do that, but we can't in this instance. So we're going to go ahead and multiply. This is going to be a cube root on both top and bottom. And then we just have to determine what is going to go inside that cube root. So remember, we're going to do the square roots. Square root of 2, who knows what that is. Or the square. So unless you know the square root of 2, we're going to go ahead and use the square of 2, which is 4. And then for the x to the 14th and the y to the second, we're just focusing on the bottom here. We want to get those to a cube. So cube variables, x to the third, x to the sixth, x to the ninth, x to the 12th, and x to the 15th. X to the 14th isn't on that list, but we can get it to the y to the, or to x to the 15th. y to the second isn't on that list, but we can get it to y to the third. In order to get the x to the 14th to y to the 15th, we just have to take it, or to x to the 15th, we just have to take it times x to the first. And then we'll ultimately end up with x to the 15th, which will come out. Y to the second, if we can get it to y to the third by taking it by y to the first, we'll get it to y to the third, and that'll make it a cube. So whatever you determine for the bottom, make sure you duplicate on the top there. So we've got cube root of 20xy on top. On bottom, cube root of 8x to the 15th. Remember, you're adding those exponents. And then y to the third. Everything on the bottom should be a perfect cube. So 8, cube root of 8 is 2. When we take out the x to the 15th, remember you're going to divide the 15 by 3. So we've got x to the 5th now. And with the y, you're going to take the 3 divided by the 3. So you've got y to the first. You don't need to write the 1. On top, cube root of 20xy. And you do want to check to see if there are any cubes inside that cube root. So 1, 8, 27. Obviously, 27 is too big to be in 20. 8's not a factor of 20. So no simplifying the number. And that's as far as that goes. Number 7. So we've rationalized denominators that had square roots. We've rationalized denominators that had cube roots. Now we're going to rationalize denominators that are binomials that have square roots. So binomial just means we have two terms in the denominator. And the way that we do that, the way that we rationalize binomial denominators with radicals, is we multiply the conjugate. And the conjugate, so we're going to multiply that. The conjugate is just the same binomial, only the sign in the middle is going to change. So instead of 5 minus square root of 6, it's going to be 5 plus square root of 6. And you're going to multiply that on both the top and the bottom. And while you're working on this, you may not necessarily write it out like this, but just to highlight exactly what's happening. We've got 2 on top times that binomial. So 2 times 5 plus square root of 6. And then on bottom, we've got the one binomial. Put that in parentheses, times the other. And then on bottom, you can FOIL. But with conjugates, there's actually a shortcut that you can take. You can multiply just the first and the last. So if we were to do FOIL on the bottom, first times first, outers, inners, last, the outers and the inners would automatically cancel each other out. You'd end up with 5 square root of 6 and negative 5 square root of 6, which would both cancel each other out. So you can skip the O and the I. So on top, we've got 10, 2 times 5, and then we've got 2 times the square root of 6. On bottom, when we do the 5 times the 5, we get 25. And then when you do negative square root of 6 times positive square root of 6, you get negative square root of 36. Positive times negative is negative. Square root of 6, square root of 6 is square root of 36. So we're going to simplify this just a little bit more. 10 plus 2 square root of 6, those aren't like terms, so we can't combine them. On bottom, though, square root of 36 is actually 6, so we've got 25. 25 minus 6. So 10 plus 2 square root of 6 over 19. Number 8, 35 square root of 5 over 5 square root of 7 minus the square root of 2. Same as on the last one, we've got a binomial denominator that's got some radicals in it. So we're going to multiply the conjugate just like we did before. So 5 square root of 7 plus square root of 2. And same thing on the top. And this will get rid of all the radicals on the bottom ultimately. So I'll write this out in a way that might seem a little more clear. So we've got 35 square root of 5 on top times that binomial. Distributing on the bottom, normally you do FOIL, but since these are conjugates, you can get away with just doing the first times the first and the last times the last. And on top, 35 times 5, 175 square root of 35. So basically all we've done is taken the 35, the part out front, times the 5. And then for the square root part, taking the 5 times the 7. So that's where we get this 35 from. And then doing 35 square root of 5 times the square root of 2. 35 on the outside, since you've basically got 35 times 1 there. And then inside the radical, 10. On the bottom, 5 square root of 7 times 5 square root of 7 is going to be 25 square root of 49. And we'll simplify that here in a bit. And then the negative square root of 2 times the positive square root of 2 is going to be negative square root of 4. On bottom, maybe you know that the square root of 49 is actually 7. So we've got 25 times 7. And then the square root of 4 is 2. $175 minus 2, 173.